Welcome back. This is Professor Xiao Ma. Earlier, I mentioned that logistic regression is the building block of neural networks. In the next module, you will learn how to go from the building block, logistic regression, to the much more complex neural networks model. Given that you know how to build logistic regression, do you wonder how to build the neural network model? I should say that although the forward propagation process will be similar and straightforward, the back propagation process is not that straightforward and easy to understand. In some sense, if you would describe the difficulty of understanding the backprop process of logistic regression as having a difficulty level of 10, then the level of complexity in the backprop process for neural network would be about 100. I hope this doesn't scare you, but rather it motivates you to want to know more. Are you ready? Dive into the videos and the book chapters if you are eager to learn how that process will work. I will elaborate those in the lecture. Many people who do not necessarily understand what neural networks are and how do they work think of neural network as one thing or one kind of model, but that's not correct. Do you know the difference between multi-layer perceptron model, fully connected neural network model, or deep neural network model? This is perhaps one of the strongest reasons that you are interested in taking this course. In fact, when it comes to deep neural networks, it is not simply a subcategory of the neural networks. It almost opens the door to another universe of different kinds of models. And those models may somehow look like entirely different. Finally, I'd like to point out that so far you have been building the model from scratch. You should be proud to say that now you understand the black box of how those models work, because one can't really build something from scratch if he or she doesn't know how it works. And doing that helps you feel the confidence of understanding these models. But the point of building those models from scratch is not to simply use them. There are rich open source libraries and packages available that you can download and install instantly, and they include a wide range of models, including the models that we have talked about. And those packages are mature and fast. They are built using programming languages that perhaps work more efficiently than the codes that we built from scratch. We should make use of the libraries and the packages that's already available rather than reinventing the wheels. A very popular and useful package is scikit-learn. We have been using some of the utility functions and objects from that package. In this module, besides building a neural network model from scratch, we will then learn how to use the packages and quickly build and train a neural network. Beyond scikit-learn, the next step would be to learn how to use keras package, which is built on TensorFlow, which you have already heard about for many times, I believe. And one word about TensorFlow. In fact, TensorFlow is not particularly a package built for neural networks. It is more of a math library, similar to NumPy that you have been using. Keras is more of a neural network package that builds upon the math operations and the functionalities of TensorFlow, so that the neural networks can run very fast by using TensorFlow. So don't be mistaken. When you say you can build neural networks, do not say you know how to use TensorFlow to build neural networks, but you say you know how to use keras to quickly implement a varieties of neural networks. And by the way, you know that keras is built upon the foundation of the TensorFlow. Alternative to keras and TensorFlow, you can also learn how to use PyTorch, another alternative but also high quality package that can come in handy when it comes to neural networks of different flavors. Does this excite you? I can't wait to dive into the module about neural networks. I will see you in class.